All right. Hello, everyone. It's great to see a bunch of known faces, bunch of friends. Also, hi, Martin. And it's great to see a lot of new faces because indeed, I'm glad that this technology is growing, that this community is doing great. So we're going to talk about the TLOG ecosystem. We're going to try to go over a bunch of different things that are happening and talk about how they fit together. Because I feel like at this point we're getting large enough as a community that people that sit over there don't necessarily know what people that sit over there are doing. So since we do have new people, a bit of introduction. I'm Filippo. I've been one of the maintainers of the Go cryptography standard library since 2018. I've worked on the Go checksum database with Russ Cox when I was still at Google. I've left Google in 2022, and now I run organizational professional maintainers, which is not the topic of today. Anyway, I've worked with the SIGSUM folks on the SIGSUM specification and on witnessing. I've worked on Sunlight. I've worked a bit on photosynthesis, although that's mostly the work of the Chrome folks. So, let's start by just talking about what is this about. We all care about transparency, but humor me. Let me give you my version of how I think about transparency and why I'm excited about it. So what we're building is globally consistent append-only lists. We're building these magic lists that if you're the owner of the list, you can add things to it, and then magically it will be in everybody who looks at that list will have that full list of append-only entries. Okay, what do we do with it? What we do with it is that we can bring accountability in places where trust is either not sufficient or too hard. We've been trying to bring strong trust to package ecosystems forever. We'll get people to manage their keys and they will sign releases of their software and will only accept things that are signed. And what happens if they lose their key? Well, issue. And from the other side of the spectrum, we had, we'll just have a central entity, a registry that will just publish the things and we'll just trust it, right? And they can always sign it, so we can have that registry just put a signature on everything it publishes, so that at least it's offline verifiable and it has no repudiation properties. That was still not satisfying because, for example, the Go community doesn't necessarily trust Google to tell it the contents of every single package, right? So that's what makes me excited about transparency. Transparency is a tool to both capture the efficiency of centralized systems, like having a central mirror for all of the Go packages, and at the same time providing accountability for the entity that publishes those, without having to go all the way to the full trust of putting keys in the hands of developers, which are definitely going to misplace them, and so that will need some break glass mechanism, which will essentially bring the whole thing down. So that's what those magic lists do. When we have a magic list that you can add entries, and once you add an entry into that list, it's magically everywhere, we can hold the list owner accountable for what they put on there. And that's both easier than strong trust and stronger than just blindly trusting the operator. The one thing is that it needs a monitoring story. You know what animal I'm thinking about. Okay, we'll get to that, but the one thing that is still necessary to make this work is that somebody needs to look at the list. Even better, when designing the list, there needs to be a believable story for how somebody would go through it and say, what's that entry? I didn't publish that. So there needs to be a way to actually look at that list and call out and use the accountability to call out the list operator. Okay, so a bunch of stuff you already heard. the point about monitoring, I really like what Alex Gaynor says about signatures and backups. You probably already heard me say this, but just like backups without recovers are useless, signatures without verification are useless. And in the same way, logs without monitoring are. Yes, fantastic. Thank you. It is early morning. I get it. I truly appreciate it. All right. So let's talk about the tools we have and how they fit together. Let's start at the bottom of the stack. Let's start with specifications. Specifications are the layer we sit on top to interoperate with each other to build tools that are reusable. So the original one, RFC 6962. Everybody can say these numbers by mind. We ascertained at dinner yesterday. Truly, the last thing we're using from RFC 6962, I think, is the Merkle tree. So the actual specification of how to take a list and hash it all into a single hash at the top with efficient inclusion paths into it. So maybe we should extract that? Unclear. Anyway, that's where we started at 10 years ago, and then we slowly moved piece by piece. So the core interoperability tool of the TLOG ecosystem is the checkpoint. The checkpoint is nothing else than the signed tree head. It's a name for the log, so that we have an identity, origin line, which is the thing that witnesses, for example, will index logs by. A size, so a specific size of the append-only log, and the hash of the tree head, which is the hash at the top of that Merkle tree. It's a signed note, which is nothing else than inline signature format for textual data. And it will have co-signatures by both the log and witnesses that essentially say, yes, that is consistent with everything I've ever seen from that log based on the origin line. So witnesses, how do witnesses talk to each other? That's the other spec, TLOG witness. TLOG witness is instead not a format, but a protocol. It's a protocol for logs to say, hey, I made a new version of the log, which is longer. Here is the new version. Here is a consistency proof with the previous version you've seen, dear witness. Please give me back a signature which says, yep, I confirm that this is consistent with the previous version I've seen, and I will remember the new version so that anything I sign in the future will have to be consistent, append only with what I've seen. So we've got the checkpoint, which is the interchange format between these entities, and TLOG witness, which is how they talk to each other. Co-signatures don't have to only have the semantics of, yep, I have checked that. I have checked consistency. The good thing about checking consistency is that it is extremely low in terms of resources. A witness has fixed state per log because it only has to remember essentially the last checkpoint it has signed. It needs to remember the log name, the size, the hash of the last thing it's seen, and arguably the signature so that it can prove why it cosigned the thing it cosigned. But we could also want, for example, a cosigner that says, yeah, not only have I checked consistency, but I've also had received a copy of the entries in the log. And that's what TLOG mirror is for. We can come up with other things that cosigners can do and other semantics to attach to the specific cosignatures that specific entities do. But even TLOG mirror uses this protocol as the base to exchange checkpoints, and then it has a sidecar endpoint to receive the actual entity, the actual entries before it produces the cosignature. Finally, how do we serve the log? Because so far we talked about the format for a log tree head. We've talked about how they exchange synchronously with witnesses. Finally, TLOG tiles is a way to serve the Merkle tree and the entries at the bottom of the tree as static entities, static artifacts, so that they can easily be cached, so that they can easily be mirrored. So TLOG tiles is extracted from the Go checksum database designed by Russ Cox, and essentially works by cutting the Merkle tree up into tiles, dropping everything that's not the bottom row, because you can always hash things up to recover those, and serving those as static files. Great. So what do we miss? We have a couple specifications that we still need to complete the picture. One is a specification for the actual proof format. We do need to prove to someone that something was included in a log. And I like to call these spicy signatures because we can make these offline verifiable. And our offline verifiable proof is nothing else, fits very neatly in a digital signature slot. Because if you think about it, a digital signature is just an offline verifiable proof, publicly offline verifiable proof, where given a public key and a signature that certifies a message. So the message is the thing that's in the log. The public key is the policy of which witnesses need to cosign a checkpoint. And the signature is this. The signature is nothing else than at what index in the log is this entry, an inclusion proof up to a checkpoint, which has witness co-signatures. And I like to put a context hint at the bottom because it's useful to have a little information that can get hashed, for example, into the leaf. For example, if you're signing a file, it could be the file name. If you're using a log that has a context field, it can be a context field. This also fits in the digital signature box because modern digital signatures have an additional data / context field. So I think that's a good idea, but anyway, this does not exist yet. We do need to specify that. SIGSUM has an offline proof already, which is pretty SIGSUM flavored in that it uses key hashes. But this is something that I'm planning to work, and I think we should get to. And then once we have the signature, we also need a public key format. And the public key format is nothing else than a policy of which witnesses need to cosign something in order for it to be acceptable. SIGSUM already has a policy format. I think Tessera already supports the policy format for configuring logs, because logs need to know which witnesses to go ask to. And I think this one just works, so great. And it is also nice how specifications have converged from different places, from different venues, the IETF, C2SP, SIGSUM, and we're finding ways to work together and interoperate. Great, so we have a substrate of shared specifications. On top of that, we can build shared code. There are packages. The original Go checksum database packages have held up pretty nicely. The main difference is that they have configurable tile height, which we kind of did away with because everybody was using 8, and 8 is a nice number, so we're just going to keep that. And then there's Torchwood, which is nothing else than a library of useful tidbits and things for working with the specifications we just talked about. So this is more for the library point of view. And by the way, I'm very happy to take PRs to Torchwood because it is intended to be essentially an extension of the TLOG and Node packages, which are sort of frozen and Go specific. But they share types with the Go packages. So this is libraries. And then there's Tessera, which is essentially the generic log implementation. And to be clear, in case it's not clear by now, I'm not talking about stuff I did here. I'm talking about stuff that everybody in the community did. And case in point, Tessera is built by the Trust Fabric team at Google. So Tessera is a library and a service to run TLOGs that follow all of the specifications we talked about. They support witnessing, TLOG tiles, and so on, and that can store the log in things like S3, GCP, or local POSIX file systems, which is what we're big fans I think there's a talk by Filippo and Roger today about Tessera, so I will not spend that much time on this. Okay, so we've got specifications, we've got code to work with them. We still need something on top of that, and that's shared infrastructure. This is something pretty special about transparency, in that the hard part is the part that you can't build alone. Usually systems, you can just build your thing, and at worst, you are interacting with a peer. Like you're implementing TLS, you still have to think about what the peer will do, but you're doing your implementation. For most services, you're just building a thing. Transparency, by and large, unless you're in one of those cases in which gossiping works, you generally need third parties for that witnessing that we're talking about. Witnessing lets you lets transparency protect the system that would be the same system that would do the gossiping. Anyway. So the hard part, by and large, of any of these projects is not the engineering. The hard part is when you get to the end of the project and you're like, well, then we just need to get the third parties. And the lawyers start asking, wait, what do you mean? And the SREs start asking, wait, what SLA are we getting from those third parties? And that's the hard part. So I'm very happy about two things. One is the public witness network. We've been talking about this for a while. There's now a website you can go to. And what you'll find there is two things. One is a table of public use witnesses. This is the table of testing witnesses because the network is in the testing phase. And these are public benefit witnesses, witnesses that are operated for the witness ecosystem. Why is this possible? Filippo, are we building another city ecosystem where incentives are not clear? Well, witnesses are cheap. That's the trick. So we're not asking the organizations that will run these public use witnesses to expend large amounts of resources. They just have to stake their reputation on not being malicious about how they operated, and ideally to operate them for long enough that there's not a bunch of churn. So you'll get a list of witnesses, and what do these witnesses commit to? They commit to configure a list of logs. So if you have a log and you want to get witnessing for this log, you can request your log to be included in this automated configuration file, which will get shipped out to all of the witnesses that are part of the network. Then you configure your policy for a subset of the witnesses, the ones you trust, the ones your community will trust. And now you have solved that third-party problem using a quorum, so you are not relying on any specific witness. Great. These witnesses are already implemented with a number of different implementations, which I'm pretty happy about because it's not a monoculture, and that's downstream of how the witness job is, again, cheap and pretty simple in terms of specifications. We've got light witness, sunlight is also a witness, there's the armored witness, there's omni witness, developed all by different teams. Okay, so that solves the witnessing part. Some projects don't even need or care to run a whole log. I think we actually made it very, very easy to run lightweight logs that then use the witness ecosystem. And you don't even need to run a service to run a log. You can just have a POSIX file system backed log. But in some cases, you can go even more lightweight. And that's using public log multiplexers. You might already know about SIGSUM, about Record, but why am I calling them log multiplexers? I'm doing that because if you squint, SIGSUM, for example, is a system where you sign something with your ED25519 key, and then you send it to SIGSUM. And SIGSUM will store two things in an append-only log: the hash of the public key that did the signature, and the hash of the thing that was signed. If you think about it, what you're doing is that you're making a sublog. You can carve out the log of things signed by a specific key. And there isn't really a semantic difference between taking Tessera and running your own log for those entries, or signing them with a public key and sending them to a checksum log. You are still creating a magic append-only globally consistent list of entries that you are responsible for. In one case, you're also operating the log. In the other case, you're delegating the log operation to a log multiplexer, which is checksum. Record is similar, except the identity, the way that the log is multiplexed based on is not public key hash necessarily, but also supports OIDC identities. So essentially, you log in if you squint in a way to record with your OIDC identity, and then you give it attestation or an artifact. It's specifically geared to software supply chain, but conceptually you're still logging in, adding something to a log that can be demuxed into just the list of things that were signed by the specific identity. Cool. So this is also a fantastic shared infrastructure that's available for projects that don't want to even take the overhead of signing up for the witness network. Great. Okay, so let's briefly talk about the things built on top. This was all of the stuff that the substrates we have, the specification, the code, the infrastructure that let us build transparency. Now, the one that I care deeply about, of course, is the checksum database. A checksum database is, we talked about at the beginning, is just a list of all of the versions of the packages, of all the packages in an ecosystem. All the packages. That's the beauty of checksum database approach. On day one, the Go checksum database had 100% deployment because we just turned it on. And everything that was fetched by the Go client had to be in there, and Google would just fetch the thing, hash it, put it in the checksum database. If Google were to lie, Google would be accountable for it. It also had no operational issues, no key rotation issues, no key compromises, nothing since day one, which is not that hard because it's just a list, but that's the point. If we were to delegate keys to operators, that would cause a lot more issues. I'm excited for other package ecosystems to do similar things, and I think Hayden is going to talk about that. So I'll let him talk about it in his talk. The Go checksum database also has a monitoring story that I'm very happy about. That's GopherWatch. GopherWatch is a third-party, completely community-operated, built by Mikhail, who will, again, talk about it, I think, tomorrow. You can sign up and get an email every time a new thing under your package name shows up in the checksum database. So that keeps the checksum database honest. Then there's key transparency. Key transparency is a deep field which I don't claim to be an expert in, but often and again, key transparency then has a problem at the top, like fill this gap here, where it says, well, we also need a way to make globally consistent the list of epochs. And there are some amazing solutions to that. For example, we'll just pay Amazon to make the S3 bucket a retention bucket, which, I mean, I honestly love, but also we just built a magic list of globally consistent entries. So, if you're building key transparency, we've got a couple excellent talks on key transparency, one by Brandon, one by Melissa. So I'll let them talk about that. Certificate transparency. Certificate transparency got it all started, which means has a lot of legacy. There's static CT, which is an attempt to move the to move CT into the specs we just talked about. Static CT API is really TLOG tiles with a mustache on to improve compression. It uses TLOG checkpoint. You can do witnessing to it, and Tesseract actually shipped that before Sunlight, which I'm extremely happy. And there are a number of implementations already, so Sunlight, Azul, Tesseract, and more. Even more exciting is Merkle tree certificates. There's a talk by Joe on this, so I'm not going to go deep into it, but this is probably how we would build CT today using all of the things we have. It removes SCTs and replaces them with spicy signatures. It actually moves the logs into the purview of the CA, which is the one that's actually adding the entries, which also removes duplication, which means the same cert doesn't have to be in a bunch of logs because the CA is the one that publishes it. And it does nice tricks to reduce the entry size because you can do a lot of things if you think hard about what you put in the log entry. There needs to be enough to help monitors, but everything else can be hashed if you don't need monitors to know about it. All right. Firmware, again, excellent talks by Frederick and Andrea and Billy Lowe, so I'm not going to go deep into this, but the fact that we have offline verifiable proofs makes them work on things like bootloaders and firmware. CLIs, I'll probably take a line in talk to talk about that. I have finally built a thing and I called it spicy. I wanted to call something spicy for a while, you know that. All right, and finally, what new things are coming? We've got new applications coming down the line. We can think of about a number of things to build on top of these substrates. We can build logs of Git pushes, of websites, social identities. Blue Sky has this PLC thing, which is basically shaped like something that would fit in transparency. Again, Michael Rosmer and Dennis Jackson are giving a talk about web transparency, so I'm excited about that. And then more monitoring. Here comes the owl. We are not building enough monitoring tools. We need monitoring that's reliable, that is silent, and Rasmus is going to talk about silent CT, and he'll talk about what we mean with silent, something that doesn't tell you unless something went wrong. And verifiable. Which instead is Martin's talk. I'll let him talk about that, but this might be the last substrate piece that I think we need, that I'm very excited about, because this will make it efficient to do things that right now require fetching the entire log. And that can be figuring out which versions of a package are in the Go checksum database. That can be demuxing a multiplexed log like Sigsum. Right now you have to fetch an entire Sigsum log with a verifiable index. You could just look at the entries that are relevant to you. And for CT, of course, not fetching the whole log from the poor CT log operators, which pay for bandwidth through the nose. Not us. We are not in the cloud. Anyway, all right, this is it. Thank you very much, and I am so looking forward to this event, and thank you all so much for coming. Thanks, Kat, and thanks, Glassclar, for organizing this.
All good. Round of applause for Filippo.